Hello everyone, my name is Logan and welcome back to the lecture hall. For today's video, we are covering section 6.5 of our UCI Math 2B series, or basically Calc 2. 6.5, the average value of a function. So, if we have our function, what if we wanted to find the average value? So, well, that looks complicated, right? We know how to calculate averages. If we had a string of numbers, maybe we had a string of y's, such that we had y1 to yn, where there are n numbers in our string, we know that our average value would just be all of them added up and then divided by n, because that's how we find averages. We've known that since probably second grade. So then we get y average is equal to y1 plus y2 plus ... plus yn over n, and we find our average. And that's pretty self-explanatory. But what if we have a continuous function? We have an infinite amount of points. So if we're like, okay, well, we'll take this point, and this point, and this point, and this point, and this point, boom, boom, and we start taking a bunch of points, well, it would be impossible to count by hand to actually add up all of our points. But what if instead, and then the other thing that we need to notice is, well, what is the distance of this interval? Because here we divide by n, well, here we would want to divide by the distance of this interval. And so what does that mean? Well, that would just be equal to 1 over b minus a. And so that's the distance of our interval. And if we wanted to add up an infinite amount of points, well, that would be the limit as n approaches infinity of the sum of f of x star I, and then we look and we're like, wait a second, we know this. This is equal to just the integral. So we can say that the average value of the function is equal to 1 over b minus a, integral from a to b of f of x dx. And this is going to be the average value of our function. So what that basically will do, it'll give us some c such that f of c is the exact average value, maybe right here. So if we want to describe our average value of a function in a very mathy way or a professional way, we can do it with this theorem, the mean value theorem. And we know that the mean of something is the average, so it's quite obvious that this will give us the average of our function. And this is the mean value theorem in terms of integrals, or for integrals, because we already have gone over our derivative one. And so what does it state? Well, if f is a continuous function on a to b, then there exists a c in a to b such that f of c is equal to our f average, which is equal to 1 over b minus a from the integral of a to b of f of x dx. And this is also the same thing as saying the integral of a to b of f of x is equal to this f of c times b minus a. And so how do we get that? Well, we just multiply b minus a on both sides, and then we get f of c times b minus a equals the integral from a to b of f of x dx. dx. That's important. Never drop the dx. Professors will drop a point or more. So this is basically our entire section. And what we use this for is if we want to just find maybe what is the average of our function. Well, we can do it very simply by just using integrals. We don't have to add up an infinite amount of points. Not that that is even possible in the first place. So let us transition to some practice problems. Now on to our practice problems. We're going to be doing number 5 and 15 from the section in our book. And so number 5 states, find the average value of our function f of t is equal to e sine t times cosine t on the interval 0 to pi over 2. So we know what our formula is. It's going to be 1 over b minus a times the integral from a to b of f of t dt. What is our b? What is our a? We first need to establish those. Well, our b is going to be our pi over 2, our a is 0, and then what is our f of t? Well, obviously e sine t times cosine of t. That is the function we're dealing with here after all. So we start up and we say that f average is equal to 1 over pi over 2 minus 0, which is just going to be 1 over pi over 2, which is 2 over pi, from 0 to pi over 2, e sine t times cosine t dt. And so how would we even solve this integral in the first place? Well, we have to use our reverse chain rule. We know that the derivative of e to the u is equal to e to the u times u prime. And why do I say u? Well, I'm saying that as a substitution because if we're taking the derivative with respect to x, we always have to multiply when using chain rule by the derivative of the inside function, and that's going to be our sine t. And then we look, well, hey, we know that the derivative of sine t is just cosine t. So this is actually quite a very easy integral. Well, this would then be equal to 1 over pi over 2, which is equal to 2 over pi, times, well, the derivative of e, or the integral of e sine t times cosine t is just going to be e sine t from 0 to pi over 2. Well, this is just equal to 2 over pi times e sine pi over 2 minus e sine 0. But we know that sine of pi over 2 is 1. And we know that sine of 0 is 0. So then we get that our answer is equal to 2 over pi times e to the 1 minus e to the 0. And we know e to the 0 is equal to 1. So we can say our final answer, or the average value of e sine t times cosine t on the interval 0 to pi over 2 is going to be equal to 2 over pi times e minus 1. And that would be our answer. Alright, so now we are doing number 15. And so it states find the average value of f of x. Big surprise, right? I mean, that's what we're doing for the entire section. And so we're actually given a graph instead, and we're like, we don't even have our function. Well, how do we do this? Well, we know the integral of our function is going to be just the area under the curve, and if we notice, this is just a lot of triangles and maybe squares or trapezoids, however you want to break it up, we can look at it like that. And so we then are like, okay, well, what do we do? Well, we just find the area under the curve, and then we divide by the interval, or I guess the distance of our interval. Well, how big is our interval? It goes from 0 to 8, so then we see, okay, we're just going to find all the areas under the curves, and then just divide that entire thing by 8, and we will get our average value. So we can start by counting up our first little section. We can be like, well, this is a 1 by 1 triangle, and triangles are 1/2 base times height. So then this is going to be an area of 1, and then we're like, well, it's under the x-axis, so it's going to be an area of -1, and then I'm like, wait, not -1, 1/2 base times height, 1 times 1 divided by 2, 1/2. So this would be -1/2. And then we look at this triangle. Well, it has a base of 2, height of 1, so then 2 times 1 times 1/2, that's just 1. And then we look, well, how do we want to break this up? I'm just going to break this up into a triangle right here. And we look, okay, well, this is a triangle with height of 2, base of 1, 2 times 1 times 1/2, 1, big surprise. And then we look, well, I'm just going to actually break this into a square, because squares are super easy to calculate. Well, base of 2, height of 2, area of 2. And then, so we look at these, and they're like, okay, well, we can make 2 trapezoids. And then we look, well, what is the area of a trapezoid? And I'm just going to write it down, and it's, well, we have our trapezoid. They're 2 separate bases, but the same height. So our area of a trapezoid is going to be equal to B1 plus b2 divided by 2 times height. So then if we look at this one, this has a base, because we're now looking at it from the other side, and our height is going to be 1. And then our base is going to be, here is going to be 1. Our base here is going to be 2. So then we get 2 plus 1 divided by 2 times 1. Well, that's equal to 3 divided by 2 times 1 is 3/2, so that's 1.5. And then, well, I'm just going to actually leave it in terms of 3/2. And then we look at our final trapezoid. Well, it has a base of 3, a base of 1, so that would be, and then a height of 1. So then this would be 3 plus 1 divided by 2 times 1. Well, that's equal to 4/2, which is 2. So we find all of our areas. And now we have to count them up. Well, we're going to do 1 plus 1, 2, plus 2, 4, plus 2, 6, plus 1.5 minus 1.5. Well, negative 1.5 plus 1.5 is 1. So we had 1, 2, 4, 6, 7. So then we can say F average is equal to all the areas, 7, divided by 8 minus 0, because that is the distance of our interval, which is equal to 7/8. And then if we kind of look at our function, that should make sense, right? Because our function does go below the x-axis, but it stays a lot around 1, but maybe doesn't always equal 1. So it makes sense that we get an average value of 7/8. So that is all I wanted to cover in today's video. As always, there's going to be practice problems posted in the comments section. Please leave a comment if I made any mistakes, if I can explain something better. I'm just trying to get better at this whole teaching thing. As always, my name was Logan. Thanks for watching. Have a great day.